In this tutorial, we forecast gross fixed capital formation for Oman using GDP as the predictor, applying the autoregressive distributed lag, or ARDL model. Our dataset covers annual observations from 1998 to 2028, with the goal of forecasting GFCF for 2025 through 2028. Opening the equation and changing the method. We start by opening our two series as an equation object in EViews. From the equation window, we change the estimation method to ARDL, since we're testing a dynamic relationship where GFCF depends on both its own past values. Why we use D-log. Notice we use D-log of GFCF and D-log of GDP rather than the raw levels. Since both series trend upward over time, using them in levels risks a spurious regression, a misleadingly strong result driven purely by shared trends. Taking the log-first difference converts each series into its approximate growth rate, which is both stationary and more economically meaningful, since our coefficients now represent growth elasticities rather than raw unit changes. Adjusting the sample. Next, we adjust the estimation sample to 2000 to 2024. Interpreting the results. Looking at the coefficients, the lagged GFCF term is 0.435, statistically significant at the 1% level, showing meaningful momentum in capital formation from one year to the next. The GDP coefficient is 0.571, also highly significant, meaning a 1% increase in GDP growth is associated with roughly a 0.537% increase in GFCF growth in the same year. The model explains about 52% of the variation in GFCF growth. The Durbin-Watson statistic of 2.07 indicates no meaningful serial correlation in the residuals. With the model estimated, we generate the forecast for 2025 to 2028 by clicking Forecast in the equation window. EViews produces a forecast graph showing the projected path of GFCF, along with standard error bands reflecting the uncertainty around each forecasted value. Once we're satisfied with the fit, we save the forecasted series under a clearly named object, so it's easy to reference later when comparing against actual outturns or updating the model with new data. We open the representation view to see the substituted coefficients and the cointegrating relationship. GFCF's lagged deviation is tied to GDP with a long-run coefficient of about 1.01, confirming a strong one-to-one long-run relationship between GDP and capital formation in Oman.